Welcome class to chapter 3, and this is tools for exploring the world of physical, perceptual, and motor development. I plan to go over about half of the slides that I have. The other half you can kind of use for the PowerPoints. PowerPoint slides you can kind of use just to take a look at some important points that I'm denoting in the textbook. If I went over everything, it'd probably be like an hour video and I'd probably put you to sleep or something like that. So try and keep these videos short to about 20 minutes and hopefully go over some important points, prepare you for the quizzes and for the exams. The learning objectives, we're going to take a look at some reflexes, determining whether the baby's healthy, behavioral states common in newborns, and temperament. Do kids have some innate temperaments that they keep throughout life and stuff like that? The reflexes, fascinating to see when you have a kid, all these different ones. Unlearned responses triggered by specific stimuli. So we have unlearned responses, help us to adapt to the world or prepare us for later development. The Babinski, toes fan out when the sole of foot is stroked from heel to toe. Blink, baby closes eyes in response to bright light or loud noise. The Moro reflex, throw arms out and then inward in a response to loud noise or when the head falls. The Palmar is reflex is grasp an object when, for example, if you put your little pinky finger in the palm of their hand, the infant will grab your hand. Rooting, you can stroke the cheek and the baby will turn and then start sucking on your little finger, for example. And sucking, when an object is placed in the mouth, the baby starts sucking it. And stepping, so when they put the baby on a treadmill and hold up the baby will start walking. Certain reflexes have survival value, rooting, sucking, and eye blinks, and other reflexes are precursors for later voluntary motor behaviors. And then if reflexes are missing or linger too long, that can be something that necessitates a more thorough physical evaluation by the doctor. And they will use an Apgar score to assess the newborn. It provides a quick assessment of the newborn status by focusing on the body systems needed to really sustain life. And they're in the 5 areas: heart rate, respiration, muscle tone, reflexes, and skin tone. Each are scored from 0 to 2, total of 10. And if you have 7 to 10, then that's good physical condition. 4 to 6 needs special attention, and 3 to less is life-threatening. Also, the neonatal behavioral assessment scale, and kind of assesses infants along these 4 systems. Autonomic, the ability to regulate body, breathing, temperature regulation, for example, body functions. Motor, ability to control body movements and activity level. State, ability to stay alert or stay asleep. And social ability to interact with people. And really all those really help doctors to assess and nurses to assess whether the baby is going to be able to do well and survive well, or if they need assistance. Newborn states, 4 states. The book goes a little more detail of crying and sleeping. Alert inactivity, where the baby's calm, eyes open, attentive, and deliberately inspecting the environment, versus the waking activity where they're kind of spazzing out. Open but unfocused eyes and uncoordinated motions. Crying, where the baby's crying vigorously, motion is agitated, uncoordinated, or sleeping. The basic cry, mad cry, and pain cry, the book kind of goes through, and what I thought was fascinating was just talking about some tricks to soothe babies: hold baby to the shoulder, walk the baby, bounce the baby, sing lullabies, pat the baby's back, pacifier, put baby in a car seat and drive, car seat on top of a dryer I've heard people to do, or a wash machine. Hair dryer, ocean heartbeat sounds. We used to have like a little lamb that would do that. And, I guess the hair dryer mimics sounds in the womb. And then swaddling, where you wrap the baby up in like a little nice tight burrito, and they kind of feel secure being in that way. Kind of like my heavy blanket that I just got, where I don't know if you heard about these things, but they kind of kind of put you all tight and supposedly release good chemicals like serotonin and dopamine. I don't know if it's been tested, but it feels pretty good. Respond to baby's cries. Should the parents do that? Yes, every time in the first 3 months. Now remember about Erik Erikson, trust, mistrust. What are you teaching the baby when you respond to baby's cries? That the world is predictable, that people are predictable, people can be trusted, people love me, respond to my needs, right? Then they say after 3 months, listen to what's going on. If you hear a loud noise and a mad cry, go check it out. Don't say like, don't want to like coddle my baby because I respond to my baby's every cries. Personally, our child was not a self-soother, and if she got upset, she would just start ramping it up, and so it would just get harder to put her down afterwards because she would just get so upset and make herself upset. So we wouldn't go through that whole wait 2 minutes, for every, month they're, alive and stuff like that, or whatever that the doctors recommend. Can't remember exactly, but we would just go in there and change her diaper, feed her, and then she'd be a happy child and then go back to sleep. Well, not most of the time, but take quite a while sometimes. Anyway, sleeping, newborns sleep an average of 16 to 18 hours a day. Oh my gosh, like cats, right? Sleep cycles, the newborns have 4-hour cycles where they have 3 hours of sleep and 1 hour awake. So you're not getting very much sleep at night in those first 3 months. And then it seems like the baby's stomach expands, can hold a little more food, and so is not as hungry, maybe as often. I don't know. Can take in more food, and so by 3 to 4 months they sleep 5 to 6 hours, and by 6 months, I call that the golden period, 3 to 6 months, before they started to get a little more upset after the 6 months and stuff. But anyway, you have REM sleep, and that's 50% of newborn sleep, 25% by 12 months. And then researchers really ask, why is there so much REM sleep early? And, there's so much brain development going on. And you have to remember that when you look at brains for alert, awake people and people who are in REM sleep, they're very similar. They're very similar in terms of an activity level. And so there's a lot of activity going on, and so it's theorized that increased REM sleep provides stimulation of the brain that fosters growth in the nervous system, all that important growth for that cephalocaudal development of growing that big head and big brain so we can figure out stuff. Unfortunately, there's SIDS, and the book kind of goes over that. Of course, that's sudden inexplicable death of a healthy baby, sudden infant death syndrome. Risk factors are premature birth and low birth weight, parental smoking, child overheating, and sleeping on stomach, and why they had and still have the back to sleep program where you put your child on his or her back. To reduce risk, smoke-free environment, put babies asleep on their backs, don't overdress them or wrap them in too tightly in blankets, don't have extra blankets and items that can accidentally lead to smothering the baby. Have a firm mattress, so kind of same thing, that the mattress isn't kind of bending over and lead to that smothering. And then healthy prenatal experience, right? Don't go there if you can, right? If you can prevent it, right? The idea is at least decrease the chances of premature babies and low birth weight. A lot of stuff that might be out of one's control, but there are certainly things that are under a mom's control with good nutrition, as we read about in the book a little earlier, no teratogens, and decreased stress. Temperament, consistent styles of patterns of infant behavior, and may range from 2 to 9 is what basically kind of people think in terms of the amount of temperaments that are out there. The book goes over Rothbard's 3 dimensions, which are surgency, negative affect, and effortful control. Surgency or extroversion is the extent to which a child is generally happy, active, vocal, and seeks stimulation, seeks interaction with others. Negative affect, extent to which a child is angry, fearful, frustrated, shy, and not easily soothed. and effortful control, extent to which a child can focus attention, is not easily distracted, and can inhibit impulses. So kind of you can look at these dimensions as possible ways you can characterize temperament of infants. Nature and nurture temperament. If we look at heredity, the nature part, identical twins are more alike in temperament than fraternal twins. And the book kind of reviews how negative affect seems to be more influenced by heredity, and temperament in child is influenced more by heredity than temperament in infancy. So you'll be able to tell a lot more once the kid grows up a little. There can also be environmental factors as well that go into temperament, where the book talks about how Russian babies are more fearful and Asian babies cry less often and less intensely compared to European American babies. And of course, parental characteristics, responsiveness reduces infant emotionality. For example, if your parent responds to you, you're going to be expressed less of that negative affect throughout your life. Depressed mothers may encourage more fearfulness in infants, the book talks about. So the importance of really taking care of oneself after you have a kid. And happy, laughing children reflect their environment is what the book talked about. And that kind of makes sense, right? Like we've talked about a lot in our discussion posts about how a healthy environment can really bring out the best in people. Stability of temperament. Studies suggest that temperament tends to be somewhat stable throughout infancy and adulthood. Temperament predisposes but does not always guarantee later personality characteristics. I think that's a key word there with genetics and nature-nurture influence, is that we may develop genetic predispositions towards developing things, and only if the environment cooperates. And the environment may cooperate in a negative way and develop some negative phenotypes that we might not have experienced had we not had those experiences, or it could bring out the best in us too as well. Temperament, like we say, predisposes but does not always guarantee later personality characteristics. Temperament can influence the environment, of course, and think about happy, easygoing kids. You know, a lot of people might want to be around them, and so they have more personal interactions, and this, of course, can lead towards more positive cognitive and emotional gains for the happy, easygoing babies versus the more difficult, colicky, negative affect babies. People might not want to be around, and they may provide them, unfortunately, less stimulation, and that's possibly what they need. It's more stimulation. Parents can nurture children to behave in ways somewhat different from their temperament as well. And so even though kids might have a negative affect, if they're provided with a positive nurturing experience, then it can keep those genes from flaring up in their phenotypic expression. For example, you might have kids that tend towards introversion, but you can provide them positive interaction where they join, team sports, and they have positive interactions that way, or, whatever it is. And that can help them to kind of balance that out. So physical development, learning objectives, how do height and weight change from birth to 2 years of age? What nutrients do young children need? What are the consequences of malnutrition, unfortunately? And then what are nerve cells and how does the brain develop? I'll probably go over through this part and kind of check the time, see how we're doing, and maybe end with this. We'll see. Growth of the body. Growth is more rapid in infancy than during any other period after birth. And you can really see it in this right here where they talk about infants double their weight by 3 months. Infants triple their weight by 1 year. If that kept on going, I think they said that as adults, these infants would be the size of jumbo jets and the length of jumbo jets, which is pretty interesting, but it doesn't go that fast. Of course, there's no one I've seen that's the size of a jumbo jet. Average is not the same as normal, so they have ranges, right? So you don't have to feel like if they give a certain number and freak out, what's wrong with my kid because, they have a giant head or something like that, like my kid did. Was in the 90th percentile for head size or something like that. Children of the same age can vary greatly in their heights and weights. Height depends largely on heredity, And infants develop according to the cephalocaudal principle. Speaking of heads, head is big relative to the rest of the body, and that's why they have trouble with balancing initially. So they don't have all those muscles that can keep that big head steady. Okay, you are what you eat, and rapid growth requires young babies to consume large amounts of calories relative to body weight, and that's why it's so important to get the kids, to get those infants to get nutrition, because all the important things and developmental processes and growth, well, not all of it, but a good deal of it, right, is happening in those early months. Breastfeeding is the best way to ensure proper nourishment, recommended until 2 years. And then there's some great benefits to it. The child gets the mother's antibodies, which means the child's going to be less ill, less prone to diarrhea and constipation. They tend to make transition to solid foods more easily, and breast milk cannot be contaminated, such as powder mixture formula with water, which water can be contaminated, so it can be contaminated to the child or contaminate the child. Bottle feeding, of course, they didn't talk about this in the book, but of course mom can pump breast milk, and then they can use that to bottle feed. And the great thing is dad can take part in that feeding too. They even have like fake breasts that dad can wear, but I just went with a bottle, type of thing. I think for a long time my kid could hold the bottle, but she was just like, yeah, right, you hold it, I don't know. We were just basically enabling her to not hold. She holds or drinks her apple juice by her hand now, so that's good. So maybe we didn't have any negative effects on that. Advantages of formula: if mother has difficulty producing milk, has essentially the same nutrients, it's more convenient. Disadvantages: has to be mixed with water, does not protect infant from disease without those antibodies, and more likely to develop an allergic reaction to the formula the infant is. Growth slows at 2 years, and children become finicky eaters, want to eat particular foods, what's known to them, and that of course has survival value for those young little toddlers that are cruising around trying out new things, and we don't want them to try out new things like mushrooms or whatever on the grass and stuff like that. Like one kid that I knew tried that out and had to get his stomach pumped twice. Malnutrition: unfortunately, 1 in 4 children under the age of 5 are malnourished. Malnourished children develop more slowly, and it's most damaging during infancy due to rapid growth rate, like I mentioned just a sec ago. The brain and the rest of the nervous system. I'm missing a title right there, but of course now we're going to go over the nervous system, or I think maybe that's a slide that I didn't mean to have, or I mean to have later. I don't know. But this is the emerging nervous system, and neurons are the basic units of the nervous system. Cells that receive, integrate, and transmit information in the nervous system. Neurons operate through electrical impulses, communicate with other neurons through chemical signals, and form neural networks. This is an example of a connectome, which is an image of these neural networks. And if you could really kind of look at it, you'll see that there's just millions of these connections. And the brain while there are specialized areas for the brain to process certain things, it's really interacting with all the different areas. And that's what really makes it one of the things that makes it a fascinating organ is its ability to interact simultaneously with so many different areas and processing information and thinking about the information all in a millisecond, and that is the neuron here. In terms of the structure of the neurons, there's dendrites, which are the branch-like extensions of the neuron with receptors that detect information from other neurons. And as you can see right here, this is the postsynaptic neuron. This is the presynaptic, whatever. It's just a term for, one over here, one over here, in terms of the electrical impulse. But let's say you're taking a look at this neuron. The dendrites here are all these little branch-like extensions that are just waiting to be communicated with. They're kind of like mailboxes that are saying, like, communicate with me, communicate with me. And remember, your brain is all communicating with one another and processing information of all these different areas and structures in your brain. And so you have the cell body, that's the part of the neuron where information from other neurons is collected and integrated. And it also has the parts of the cell that keep the cell alive and stuff like that. But so basically, the dendrites are waiting for these neurotransmitters. I'll talk about what those mean in a sec here, or I'll go over that in a sec here. The axon is the long, narrow outgrowth of a neuron that enables it to transmit information to other neurons. It's covered by a myelin sheath, and that makes it be able to, the electrical impulse to go really fast, like an insulated wire or something like that. And so that's the axon right here. The terminal buttons are the site at the end of the neuron that releases the neurotransmitters. So these are the terminal buttons. There's a bunch of them, and they release neurotransmitters. And these are chemicals that I'll talk about in a sec. The synapse is a site of communication between neurons through the neurotransmitters. And it's basically a gap right here, as it's shown right here, where literally your thoughts are composed of neurochemicals that communicate in empty space in your brain. Okay. Action potential is the neural impulse that travels along the axon and then causes the release of neurotransmitters from these terminal buttons into the synapse. The neurotransmitter are the chemical substances that carry signals from one neuron to another across the synapse. Okay, so that's basically a summary of how your brain is processing information right now, or a thought, or a memory, or something like that, whatever you want to call it. And it literally is taking a summation of all the processes or the inputs that are coming in right here from the neurotransmitters. There's some neurotransmitters that say fire, 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 and they're called excitatory neurotransmitters. And there's some neurotransmitters that say, don't fire an electrical impulse, don't fire an electrical impulse. And those are inhibitory neurotransmitters. And it gets summed up in the cell body. So all these dendrites are connecting to other cells, or other neurons, right? And other neurons are firing these terminal buttons right here, and they're releasing chemicals that are going into the synapse. And so let's take a look at the next slide. And it kind of goes over that. So transmission, the neural communication begins when there's enough stimulation in the presynaptic neuron, which is basically before the synapse, okay, to create an action potential. The action potential travels down the myelinated axon to the terminal buttons. Terminal buttons release from that action potential, release neurotransmitters. Neurotransmitters cross the synapse and fit into the receptors of the dendrites. Each neurotransmitter is excitatory or inhibitory, and it's summed together, and it decides if it's going to fire that again. That process of the neurotransmitters, they don't touch one another. They go in a synapse, and they carry signals from one neuron to the other. The receptors are specialized sites that specifically respond to certain types of neurotransmitters, like a lock and key phenomenon, and that's what I'm going to show you right here. So remember that terminal button, it got an action potential, it got fired. What did it do? It released neurotransmitters. The neurotransmitters then go seek to try and find out this lock and key phenomenon. And so the neurotransmitters will attach to the receptor when they find that lock and key phenomenon, and they are either going to be excitatory or inhibitory. And then again, it sums all that up based on that communication to it, and then it decides if it's going to send another impulse down there. Book goes over the cerebral cortex, which is the surface of the brain, the folds in the brain. There's various aspects of the cortex that can be divided into, 4 areas here. The frontal cortex, really a lot of people talk about the prefrontal cortex, and that has to do with planning, decision making, that type of stuff. The parietal cortex has to do with processing of body sensations and motor. The occipital cortex has to do with processing of vision, and the temporal cortex has to do with hearing And it has advanced visual processing, probably because the fusiform gyrus is in that area. But as you can see, a lot of it relates to processing information from your senses. And then the prefrontal cortex has to do with planning and aspects of your personality, empathy, that type of stuff. The emerging brain structures. At 3 weeks after conception, the neural plate, a flat structure of cells, forms. By 28 weeks after conception, the brain may have all the neurons it will ever have. And in the 4th month of prenatal development, axons begin to form the fatty sheath, the myelin, and it helps spread neural transmission, improves coordination and reaction times. In terms of, so that's kind of the beginning of the brain and how it developed, right? And that tube where it encloses. And the number of synapses peaks at about 12 months, and then the brain goes through a process of synaptic pruning, where the gradual reduction in the number of synapses, beginning in infancy and continuing until adolescence. And it basically weeds out unused neural connections. The pruning is first completed for brain regions associated with sensory and motor functions, then basic language and spatial skills, and then lastly attention and planning, kind of showing that epigenesis of different things in terms of human development and what people go through. And as you can see with the attention and planning, we'll see that later, there's a battle between that prefrontal cortex and the want of those teens to experience immediate pleasure. Growth of specialized brain mapping methods. You can take a look at studying children, unfortunately, that have had brain damage, and if they have certain, functionality that was impaired, you can basically imply that that certain brain area that was damaged is related to that functionality. EEG, or the electroencephalogram, you can look at children completing various tasks, for example, a memory task, then look at the brain's electrical activity through electrodes placed on the scalp, and then the brainwave activity, of course, indicates that specific areas are being used. And another way to look at it at the brain is through fMRIs, not as convenient as the EEG. Stands for functional magnetic resonance imaging, because you have to go in this tube, it's more expensive. Uses magnetic fields to track brain flow, and the idea that blood flow, and that blood flow indicates brain activity. The 5 general principles of brain specialization. I kind of thought that this was fascinating and really talking about how the brain develops, and also the influence of environment and genetic influences as well. Specialization is evident early in development. Damage to the prefrontal cortex of infants impairs decision making, creates abnormal emotional responses. Left hemisphere shows increased activation in response to speech, which basically shows that there is a language acquisition device. And right hemispheric damage impairs certain kinds of spatial relations. So it's really talking about how there is specialization early on, really, when the child is born, to help the brain and the child develop, the infant adapt to the environment. The specialization takes 2 specific forms. Brain activity during processing becomes more focused and less diffuse. And they talk about the activation of the fusiform gyrus when seeing faces, and kinds of stimuli that activate processing shift from general to specific. Faces rather than random pattern blobs activate a specific area. So they're really talking about the specificity of the areas of the brain and the specificity of how infants respond to the environment, and being able to distinguish faces from something that looks like a face but just has random blobs and stuff like that. And the book talks about also in terms of becoming familiar with familiar faces, and how infants can do that at a very early age as well as distinguish mom's voice and music preferences, stuff like that. So really we're talking about this idea of that the brain is really well prepared to adapt to the world, right? Right out the go. Let's see, different brain systems specialize at different rates. Reward centers related to peer rewards, top in teens, while prefrontal cortex is not fully developed until the age of 21. That's why teens have difficulty with peer pressure and delayed gratification. And that's the interesting thing, right? Is I think Mark Twain said that when I was 17, I couldn't believe how ignorant my father was. And when I turned 21, I couldn't believe how much he'd learned in 4 years. Well, it's not that the dad learned that much in 4 years, but the kid's prefrontal cortex became more developed. And then thus he was able to refrain from immediate impulses, immediate gratification, and delay those things and plan things out and make decisions based on long-term goals and self-management and stuff like that, which tends to occur later. Different brain systems specialize at different rates. Just talked about that one. Environmental stimulation is necessary for successful specialization. They talk about two concepts here: the experience expected growth, experience dependent growth. Experience expectant growth has to do with how the evolutionary brain has a preformed structure built through natural selection, language acquisition device, object permanency, taste aversions, face and voice recognition. And that interacts with the environment to produce brain structure. And then there's also ways in which brain structure, a person's unique experiences over a lifetime, influences the brain structure. And think about the taxi driver and their hippocampus getting really big. And then the idea of growth mindset and neuroplasticity, which is the idea that your brain can grow new connections, right? And learn new skills. And thus you can overcome some of your genetic deficiencies. Plasticity is a benefit. Lastly, speaking of plasticity, it's a benefit of the immature's brain's lack of specialization. And that's why younger children tend to respond better in terms of treatment and recovery from brain injury versus older children and adults. It's because their brain hasn't fully specialized. Yes, there is some specialization, but there's also some room for covering for a certain area of the brain if it gets injured. And the brain is more effective at reassigning functionality, creating new neural pathways to the brain prior to the brain being fully developed and specialized. And I think I'll end right there. The rest of the slides go over different things about motor skills, perception, all those great things. And hopefully these slides will be really helpful for you, as well as the theory of mind and self-awareness for the quiz and the upcoming exam after a while. Okay, take care.